what generally happens is that some people come up with some cutesy things, and I'm all for that. But then someone comes up with a raunchy one that they don't want to share. But it's the easiest to remember, so everybody else uses it. And we had the same thing. You got this with, when you did the wrist bones, yeah, that type of stuff. There's another one for the cranial nerves. There's a whole bunch of them. And then when the raunchier they get, the easier it is to remember. But I go with the cutesy ones. One student made theirs about me. And I like that one.
Do they get extra credit for that, or?
They didn't. How many times have you seen me give extra credit? So let's talk about entrance skin exposures. So for an ESE, we do call that like a minimum or maximum. Maximum, right? So maximum doses at the skin entrance level, right? And then when we actually get a dose, when we get our doses, if we go by an entrance skin dose, then that exposure is, we're being cautious, right? Because is it actually accurate? It's not actually accurate, it's a higher estimate. So we have two ways of doing it. We could go with a low estimate or a high estimate. Everybody always goes with a higher estimate because that's cautious, right? Are there any, remember I said that whenever there's a federal rule, that's important because it will come up on the registry. Are there any federal rules that apply to entrance skin exposures?
The fluoro one?
Yes, what's that one?
11.5 R per minute.
Exactly. If it says NRC or FDA or our national, what do they call it, the National Federal Code, if it's any of those where they say you have to have a minimum of this much lead in an apron, you have to have the entrance skin exposure, can't go over this, all of those are important numbers. As we go along for 2 years, every time something comes up that's in the federal code, we will say, remember this because it's on the registry. If it's on the federal code and it's worth remembering, then it will be on the registry, right? Because those are there to protect patients, and that's the ART's biggest thing, is to protect patients. Do you remember that we talked about entrance skin exposure, and it wasn't in your book, but I put it as a question on your quiz? You remember this? It was about generators?
Yes. Oh, yeah.
Right, so, very quickly, let me explain this one. So this is a cine wave, right? So that's a cine wave. We're talking about electricity that's coming into our generator, right? So we got the power that comes in from the street, it goes into the generator, and then in the generator it's changed. So this would be considered single phase power. This is what I started out with. So with single phase power, this is the section where we have power. This is the negative part, there's no power. So if we set 90 kV, right here we get 90 kV. The line is 0, and anything below this line is 0. So we would get this pulsating electricity to our generator that went up to 90, back down for a whole cycle to 0, back up to 90, back down to a whole cycle for 0. Not very efficient. Not very efficient because when it's at 0, it's not producing any X-rays. Right. Then we go to another generator, and this is a 3-phase generator, so it's a 3-phase generator, and it doesn't go down to 0. It doesn't go down to 0, and we have 3 peaks here, so we have more efficiency. And then And yeah, that could be with 3, but it also could be with 6 pulses. And so now we're even higher. It can actually go up to 12 pulses. And now we're up around 96% efficiency, right? Because it drops a little bit at these small little valleys. And then, so that's very efficient. So now when we have the X-ray beam on the single phase, we had to use 1 second. But on the triple phase, we only had to use 1/3 of a second. And on the triple phase with 12 pulses, we only had to use 1/10 of a second. Now, then there's the top one, and this one is, and that one is, this is called high field generator, and this one is almost at peak 100%, it's like 99%. So that we use less time, so the patient gets exposed to less radiation, the more efficient the generator is, right? So remember this, it was part of your quiz when we talked about the different types of generators, and you got your quizzes so you can study. I got a very similar question about what effect does the generator have on the patient's dose. The more efficient, the less dose they get, yeah? Oh, do I really have to go over these? I don't have to go over, there's about 10 questions, it looks like, on the eye. On the eye, we just did that one, you just got that one back. You know, the Rod's law, the Cohn's law, scotopic vision, photopic vision.
Do we have to label it again?
No, there's no eye to label, but you've got to explain what are the rods used for, under what conditions do they work best, what are the cones used for, under
All
what
the stuff I
conditions do
studied
they
for last time,
work
but
the
I didn't
best.
need to.
And the difference between scotopic and photopic vision, what type of light that each of these cells work best in. Then I got another question about scatter. And so if we have a lot of scatter, how can we reduce that scatter? What are ways to reduce scatter?
Grid?
Grids.
A grid? Your grid is a great way to reduce scatter reaching the eye. Filtration. Say again? Reducing your field size, collimating, a great way to reduce scatter. What else was there? A couple different ways to do this.
What if we?
Ancillaries.
Decrease
Compression bands.
You could decrease your KBP if you were too high, producing too much scatter, because KBP, the higher we go, the more scatter we should get. Right? So,
What'd you, compression band?
compression, yeah, that is a way. It's a weird way, but it is a way. So there'll be a couple questions on that you'll just have to critically think about scatter. And so those are things that affect scatter. What else? The volume of material that we're X-raying, the atomic number of the material that we're X-raying, right? If it was a higher atomic number, we're gonna get more PE. So if it's a lower atomic number, we'll probably get more scatter. Yeah. The thickness of the body part that we're doing, you get more scatter off a big fat thigh than you do a skinny wrist. Yeah. Okay. these are just right from the quiz today. Oh, and then this one is an application of the maintenance formula. So you have a couple of times where you're gonna have to calculate using the inverse square law. You've got at least one or two that you've got to use the maintenance formula. You got at least one or two that you have to use the 15% rule, and you have at least one or two that you have to use the law of reciprocity.
And half value. And half value. Half value.
Say again, I'm sorry.
Half value later. She was in and half value later.
Half value there too, you have to calculate, that's pretty easy. Do you feel like you have a focus now? Because I just covered 100 questions.
So, isn't there like 300 questions? Just 100, that's it?
100.
Okay, but worth what, 300 points?
It's a 100-question test and it's worth, what does it say in your syllabus, 250 points?
300?
300?
Yeah.
Okay. Okay. Remember, don't get worried too much because your paper, I mean, if someone's got the syllabus, take a look, what's the paper worth? 50 points, that's easy 50 points. What about your homework? Yeah, by the way, we'll check homework on the day that you come back. Bring it and we'll, before we start the exam, we'll check your homework, just make sure you got it done, and then I'll add those points in too.
That's chapters through 15, right?
That'd be chapters.
Like avoided getting up at 3 o'clock this morning to do it online.
Yeah, to chapter 15. before we
I
do.
was afraid he was gonna ask for it today.
I didn't think so because.
So has anybody got the syllabus
Well,
handy?
that's like studying and stuff for the
Okay,
midterm, so.
Quizzes are 250 points, 1/4 of your grade. We're only halfway there. We've got about five or six more quizzes to go, and there, several of them are large quizzes on contrast, density, detail, and, distortion. So you still have a bunch of questions left to do till the end of the semester for that, total worth a quarter. Midterm was worth 300 points, so it's worth a little less than a third, right? And your final is worth 300, but then your research paper is worth 50, your special project is worth 50, and your homework is worth 50. Right there is easy 150 points to add on. Your special project, you remember what your special project was, because we want to start knocking those out in the last 3 to 4 weeks. Okay. Your special project, student must demonstrate an understanding of the concept of their choice presented in this course in an innovative and non-conventional manner. It means not in print. Students will present their projects in front of the class, and that's to be determined when we do it. We'll do it in the last 4 days or so. And you should come up with an idea and then ask for my approval on that idea.
Will we do groups on that?
Do what?
Do groups, like small groups for the project?
You wanna do like partners for that one?
Yeah.
You can do partners for that one if you want. And if you actually have something that you need more than just a partner, get approval from me, because I've had them where like 4 students wanted to do it together. So, yes,
So, sorry, it could be like anything, I should say like photoelectric absorption.
anything. Here's some examples of it. So, so a couple of students, 3 students wanted to do photoelectric in Compton, but they wanted to do it, they had red and blue balls. And one got in that corner, one got in that corner, and one got here. And the blue ball was a photon, and they threw it at that person, and that person caught it,